software engineer here at Irembo. And if you're an engineer like myself, you probably know that we go through a very interesting evolution. You start off maybe discovering how to code, and it changes your life, right? You feel like you've discovered a new superpower, and you're really excited. Your mind is going into all these places, and you're thinking about the money that you're going to make in your career. And then a few weeks later, maybe a month or two, you actually start to see what real engineers do in the real world, right? These guys who are contributing to open source, writing these complicated libraries for free, pretty much. And then you meet your boss or somebody at your work who's doing 2,500 GitHub monthly contributions. And your bubble is burst, okay? And you start sliding into this valley of depression. And some people get stuck there, never to return. Some may be sitting in this room who completely gave up after that. Rest in peace. Do we have anyone here? But some find the strength, the urge to continue to move on. Maybe a mentor picks them up and shows them the ropes, right? They start to learn that, you know what, HTML is actually not a programming language. And PHP is trash. and you learn the difference between MySQL and Postgres, and you become a real engineer, right? After some years of practice, you even start to do things like microservices, and you start doing Java, real languages, right? And then you realize Java 2 is trash, and I'm joking. Yeah, and then you get to that point where you're playing with RabbitMQ and React and all these really cool things. After a few years, you think you made it, right? And then you hear the word Kafka and fault tolerance and messaging brokers and streaming and all these complicated words, right? Like data replication among distributed brokers and multi-node clusters and all these things. And if you're in that space today, this evening, I just want to say that you're in the right space, right? The life of an engineer, one day you're feeling like the GOAT, the next, it's like you're starting from scratch. And what I want to do today is just to demystify this topic of Kafka. I don't want to throw you all the jargons. We've got so many experts that are going to tell you all about it. But I want to give you the intuition behind it. You see here, I realized further along in that journey that it gets to a point where you're not getting paid to write code anymore. I realized this at Irembo. We're not in the business of writing code. We're in the business of processing information. Okay, we've got millions of sensitive data points for our citizens that we need to make sure is shared among different systems in a timely, robust, and accurate manner. And at that point, you realize the real value is not the software development lifecycle; it's the information life cycle, and that's where Kafka comes in. How do we make sure that data is distributed and shared accurately between systems that don't even know each other, and sometimes within the same systems but different microservices? And so enough of my elaborate definition of Kafka. What I want to do is go straight to a demonstration, right? We've got a distinguished DevOps engineer and also a mountain of a man. I'll introduce Ben to give us a quick demonstration of Kafka. Ben, take it away, please.
Thank you, Jeremiah. So I'm going to take you through Kafka in the simplest form that I can. It's quite complex. It's a topic that we can spend a lot of hours just discussing. And we'll talk through the visuals, and then I'll show you a quick demo of how, for example, if you just want to play around with Kafka, how can you get started and what do you need to do that. So my demo is going to be based around what you see on the screen. And StreamZ is an operator. So basically, like what Jeremiah was saying, we have many people contributing to open source tools that we can use. So traditionally, deploying Kafka used to be a very, very, very complex and tedious thing, including managing it. And now we are in the era where we are getting more towards the distributed systems. You've heard maybe of Kubernetes and what it can do for us. And so projects like Streamz help us to deploy fault-tolerant Kafka clusters inside Kubernetes. So my demo today is going to be based on Kubernetes. So what you can see here, I know it looks very weird, but you can see Kafka Zookeeper, you can see Kafka cluster. These are what we refer to as Kafka brokers. You can see a cluster operator. So basically what happens is you deploy this cluster operator, and it has the definitions or manages the cluster itself. So it's going to manage the Kafka cluster and also the Zookeeper cluster. And then you have this guy here called the user operator. So if you want to go into managing, for example, authorization in terms of what basically a Kafka user is able to do, not anybody should connect to your cluster, then you get to benefit from the user operator. And that uses what we call custom resource definitions in Kubernetes. And then this topic operator basically helps you easily manage topics that you have in your cluster. So you can create many topics. You can define, for example, how long should they retain data based on the size or based on time, among other parameters. So just to elaborate more now in terms of the ecosystem and what is available for you to use, you have the Kafka cluster. And now when I say Kafka cluster, it includes Zookeeper, the topics themselves, and the user operator. Then you have Kafka Connect. Kafka Connect is a very important tool that will connect to your Kafka cluster, and then you can connect various data sources. So this could be anything. So it could be from another application, it could be from a database, and so on. And then you have these sync connectors that will take data from your cluster and send them to another destination. So down here we have Kafka Mirror Maker. So where this one comes in handy is if, let's say, you have two environments or two production environments in the terms of a disaster recovery, you have one cluster, which maybe we can call the primary, and this you can call it the secondary. And in between you deploy this Kafka Mirror Maker. So the Mirror Maker is just like the word says, it mirrors data from one Kafka cluster into another. So if you're running a cluster, let's say one in Rwanda, the other one in Uganda, then you use Kafka Mirror Maker to make sure that they're always synchronizing in almost near real time. Then Zookeeper here, of course, is very important in terms of keeping the metadata of the Kafka brokers. So it's the one that knows which broker is the reader, because Kafka works in a forward reader mechanism, and then it also keeps track of the partitions of the topics that you have. Kafka Exporter here is very important for exporting metrics from your cluster, so in case you want to visualize them using a dashboard. Kafka Bridge here, take that one as an API in front of Kafka. So if you want to interact with Kafka like how you do with a normal API, then you deploy Kafka Bridge and you can use HTTP clients. And this is just the normal way of clients connecting to the Kafka broker normally. And so now I'm going to show you a demo. Let me zoom this one in. Okay, so I've just deployed a new Kubernetes cluster a few minutes ago, and it has 3 nodes, which I'm going to use for this demo. And then I'm not going to bore you with the details of what I have here, but maybe just an overview of what we have. We have the Streamz Kafka operator, which is what we are going to install first. I believe I've created a namespace. Yeah, I have a namespace here that I created also for Kafka that we are going to deploy our Kafka cluster. And so this operator contains the logic on how to manage the cluster. So that is the first thing I'm going to install. So I'm using Helm. So Helm just makes it easy for us to deploy such projects without so much of complication, and just easy in terms of managing and updating and knowing what is where. So in this case, just running this one, and a good practice would be you download this operator on your machine and you host it on your GitHub. So what it means is if, for example, the next time you want to change the version or the next time you update, you can be sure of exactly what you're changing in your deployment. So once you deploy that, what you want to check is if the pods in the Kafka namespace are running, and now this is the Streamz cluster operator that is trying to start. But before that one starts, I can show you a few things here that of now the cluster that you are going to deploy. So you're going to create a Kafka cluster that has 3 brokers, and then it's going to, of course, use authorization and authentication. And then these are the configs of how our cluster should behave. So, for example, the replication factor here would mean any data in our cluster would be replicated 3 times. And also you have the minimum in sync replicas, for example, here. So the replicas mean if, let's say, you have 10 replicas, in this case I'm saying with only 2 replicas, I should consider the data saved. So if I have only, let's say, less than 2 replicas, then I'm not going to be able to save any data on the cluster. So checking on the operator, it's running. And now I'm going to install the cluster, the Kafka cluster itself. So as that is installing, so normally what is going to happen is going to start from creating the Zookeeper nodes. And in this case, we've added 3 nodes for high availability. And so what the Zookeeper is going to do is going to contain the metadata or the behavior and the data of our Kafka cluster. So in this case, as a good practice, of course, you mention the resource request and the limits, and you can adjust this one dynamically. So in terms of the traffic that you're anticipating in your system. On the Zookeeper, I also have the same. What is the size in terms of storage, and what are my resource request and limits. And down here, I have a very important thing called cruise control, which is kind of like a Kafka rebalance. So what happens is when you write data, and like what happens in a database where the data is automatically distributed, in a Kafka cluster, you can have one node having more data than the other, and basically it's getting overwhelmed, and that will affect your performance. So this cruise control, considered like what you have on an aeroplane, which is just touch a button and let the aeroplane do its thing. So this cruise control, in this case I'm going to enable the cruise control, is just going to take care of our cluster without us having to do much manual work. And then you have the topic operator. I talked about this one in terms of managing the topics and the user operator. And then I have the details of the user and what they can do. And then I just have 3 topics here, orders topic, users topic, and products topic, which is not enabled. So for this one, it's just for the purpose of showing you how easy it is. For example, if you arrange your components very well, let's say in a Helm chart, how easy it is for you to adjust in the future when you need to scale. So right here, the Zookeeper is ready. And now very soon you're going to start to see the broker nodes getting provisioned. And of course, at the same time, you can see the storage that is getting provisioned for these components. So you can see we have 3 volumes where the data of Zookeeper is going to be stored. In this case, they're 10 gigabytes. And also you have 3 broker nodes, which you're going to see in a moment getting provisioned. Taking a moment, but then in the meantime, I can talk to you about some very interesting thing about Kafka topics. So with Kafka topics, this one has a replication factor of 3. So means that that each, or basically how the data is going to be divided within a topic. There is a very thin balance between using a very low number and a very high number. And that would affect, of course, the throughput of your cluster. So this is a matter of experimentation between how quick you can write the data or how quick you can write the data, so you can scale to hundreds and thousands. But of course, you have to be careful and understand what are your application needs. These replicas are basically how many copies of your topic should be there. And this retention millisecond is saying, when I write data to Kafka, it should take this amount of time in milliseconds. This is approximately 1 day before it can get auto-deleted. So you can decide your data stays there for 1 year or it never gets deleted. But of course, if you want to retain the data forever, you must have enough storage for that. And then here I also have the size in bytes. This is approximately 1 gigabyte. And so what this definition means is, if my Kafka topic gets to, or my Kafka segment gets to 1 gigabyte, then automatically delete that segment. Let's check if our nodes are coming now. Yes, we can see 45 seconds ago we have 3 Kafka nodes that are almost in a running state, and we're just going to wait for one more component before we can proceed. So that component is, of course, the entity operator, which is in charge of managing the topics and the users. So that is what will enable us, for example, to kind of use Kafka user to see how many users we have, and Kafka topic to see how many topics we have. Sorry. So this, for example, to list Kafka topics. And you can see right here I have 2 topics. And from my chart which I've made, so let's say, for example, you wanted now to add. So we have orders and users topic, and you want to add another topic called products. Then you can easily come here and set this one as enabled to true, rather. And so when you Helm upgrade, we should have that topic created automatically. So in terms of the ease of managing going forward, because some of the things that will change is like retention and other configuration, it's going to be very easy for you if you use this methodology to manage your cluster. So the other important thing is how you name your topic. So that could be based on the location, based on the environment and the application, then the name of the topic. And this is going to be very useful, for example, if you use mirror maker between 2 data centers. So you're able to differentiate which topic is where, and also in terms of giving your Kafka user access to the topics. So in a moment, let's confirm yes. And now we have the entity operator here. So it's just taken us around 7 minutes to have this cluster up and running. And these are production-ready cluster, basically. So what you just need here is to use either the service name or the load balancer IPs to connect to the cluster. And what you have here, you can add topics as you go on, and it's also it has cruise control, which is also going to make it kind of self-manage itself. So, yeah. Back to you, Jeremiah.
Thank you very much. Round of applause for Ben. Thanks for that elaborate demo. You guys look a little bit depressed. Everything okay? Yeah. Do you have any quick questions for Ben? I'll take 2. Okay. We'll start with the Irembians. We've got the lady at the back and the gentleman right here. But maybe before we get those 2 questions, I'd like to introduce our speakers for today so that they could come forward. I'll start with, who should I start with? There's so many distinguished speakers. I'll start with Nsia, who I just recently met. She's a lead data operations engineer. She's worked with companies like UNICEF. She graduated with a master's from the prestigious CMU. And I think more importantly, she works on all of our USSD data as Irembo. She works with Altrans as a data engineer. And she is a dedicated expert who is open-minded about her work. Ladies and gentlemen, let's welcome Nsia, please. Thank you. And I'll... Right. Okay. Space between. For CSS experts here. All right. Joan is a DevOps engineer that I had the privilege of working with before in a previous life. I remember I needed some help with a dev cluster where we were deploying stuff like Couchbase and stuff, and she came in and did some interesting things, and after that I was like, I had to huddle her and be like, hey, who are you? I don't know if you remember that, but she's a DevOps engineer from One Acre Fund with more than 5 years of experience in DevOps. Please let's give a warm welcome to Joan. And last but not least, I don't know whether I'm more impressed by his DevOps skills or by his stature as a man. I think Ben has hiked every hill in Rwanda and beyond. Am I correct? Yes. So if you need some tips on how to get on top of volcanoes, please talk to Ben. But apart from that, he's also a senior DevOps engineer here who just gave an elaborate and some will say beautiful talk on Kafka. It's very, very difficult to do, for those who do demos, it's very difficult to do a demo one take clean without the demo gods getting at you. So you're a very blessed man. Please, let's welcome Ben. And with that, I'm going to take the first questions. I think there was a lady at the back, and if somebody could hand her the microphone so she could get us started.
Hello. Thank you so much for the presentation. So could you kindly share more about some of the use cases that Kafka is used in the context of Irembo? And also, could you share a bit more about like the producer-consumer architecture within, the context of Kafka? Thanks.
Yeah, anyone can.
Okay. So I'll start with the last question, the producer-consumer concept. And I'm just going to give an example. So consider how we are seated here as a queue. So a queue means anybody that comes after will either, most likely now in the Kafka concept, the person is going to go behind or the data is going to go behind. And so in this concept of Kafka, producer and consumer, whoever is writing data into the queue becomes the producer. And whoever is reading becomes the consumer. So the producer will produce and the data will get appended at the end of the queue, and the consumer will consume from the front of the queue. So maybe an interesting concept there is how do you determine how fast you can read and write data? Because if you're writing too much and you're consuming less, then there's a problem. So you need to consume as much as you write. So you need to balance the number of consumers you have and the number of producers that you have so that your data is moving efficiently. And your first question is on how we use Kafka at Irembo. So mainly we use Kafka to move data across microservices and also for some kind of repetitive tasks. So an example is, so say when a user pays a transaction on Momo, it goes to MTN, the user has finished paying, and we want to check what is the status of this payment. So when someone already initiated the payment, we have the data of who is paying, what number they're going to use for this payment, and what is the transaction ID that is returned by MTN. So we use Kafka to continuously check, to queue and recheck, is the transaction ready? And when it's ready, it gets removed from the Kafka, and another consumer consumes that message and, for example, updates the database, and then you have your notification coming in through your SMS or your email that we've received your payments. So that's an example of a use case that we use Kafka.
Thank you.
Thank you, Ben. I think we had a gentleman as well here.
Thank you very much. So my name is Gaban Shimge, and I'm a software engineer. My question is, why did you choose Kafka, where there are many messaging queues you can use? Thank you very much.
Yeah, very hard question, and I believe my panelists here will be helping me answer that because they're also using Kafka. But personally, for me and my understanding, and for us at Irembo, we have a use case where we want to write a lot of data. We want it to be fast. We want to be able to replay that data if something happens, let's say in the right now, we can be able to go back and kind of replay the messages that happened. We want something that is resilient, and that is what we are talking about today, resilient and fault tolerance. So what that means is now and then you have a problem with one of the servers is having a problem. So in that case, you want your queuing system to continue operating, among other benefits. You want something that you can control access in terms of who can write, who can read from your Kafka cluster. And of course, most importantly, is also scalability. So it's something that you can scale horizontally. If, let's say, you're having bottlenecks in performance, you can, for example, increase the number of producers you have, or you can expand the storage as you go. And also the ease of management of this tool, and without forgetting also the ability to replicate this data when you have another data center. So, and it has an amazing community. So if you have brokers or you Google about Kafka, how do I do this? You have libraries and other people ready to support, and a lot of people have written blogs about Kafka. So those are some of the reasons why we chose Kafka.
And it's written in Java. So I'll just ask a few questions. Actually, one question to our other panelists. How do you use Kafka in whether your current role or in your previous role? How have you used Kafka and how has it helped you? Just really quickly, just to warm us up. Yes, please.
Okay, good evening, everyone. As a moderator said, my name is Insia, and I work as a data engineer at Alltrans. So personally, from my experience, I use Kafka for my ETL processing purposes. So Kafka, as my fellow mates they have already said, it's a pipeline. So it enables you to ingest data from literally any application, any database, any source. So from the business use cases that we usually have at Alltrans, we have data everywhere. We have data in some apps, we have data in databases, we have data in the server, and we need those data to perform some analytics, data-driven analytics. So we needed to find some centralized platform where we can collect all data and we put them all together, and then from there we start doing some transformation and later loading to some data lakes or data warehouses as it comes. So that is one of the reasons to why I use Kafka as a data engineer. Another reason is Kafka, it comes with a stream processing engine, inbuilt stream processing engines by itself. So it comes with Kafka Stream APIs. Also, it comes with KSQL, which it's a two-in-one tool. So you ingest your data, you put all your data together in Kafka, and then if you want to do any sort of transformation in it, you just use for a start, you can use inbuilt tools like KSQL. So you want to do whatever data pipeline you want to create, you use the inbuilt tool. So that's also another reason. It was actually a bigger reason to why I really dived into it. And these stream processing tools, at least the inbuilt ones, they have a quite gentle slope, like learning slope. So it's not too steep. Like if you can start and you can learn it, and you can easily jumpstart your data engineering career for that purpose. Yeah. Thank you.
Thank you. Joan, yeah?
Yeah. On top of everything they have just said, because at the risk of sounding repetitive now, but mostly we use Kafka also as, she says, a streaming engine, but also the data we get, we use it to populate our monitoring tools. So ELK, especially for payments. So knowing how many transactions were successful, failed, we get data from Kafka, including everything she just said.
Okay, let me come back to Ben real quick. I was really interested in your demo because I was expecting to see graphics, but it was very much CLI, right? Or feels like you were hacking. How do you monitor this thing? Do you just look at the black screen all day long?
No, there are various mechanisms of monitoring your Kafka cluster. So, for example, what I just did, at the beginning, I showed you a component called Kafka Exporter. So that exporter is responsible for getting metrics from your brokers, from your Zookeeper, and exposing it to whatever tool you want to use. So in this case, for example, the easiest way would be if you have Prometheus, and the node exporters collecting this data from your Kafka cluster, and then you can use Grafana for visualization. So some of the interesting metrics you can be able to see is like the throughput in terms of the messages and also the network latency. You can be able to see the size of the volumes, which is very important because very often, depending on the use case, you can overwrite data and then you run out of storage. So you want to know that beforehand. And of course, you can set monitor rating for that. So you can get messages, you can get Slack messages or email notifications whenever maybe you hit a certain threshold. And maybe another important thing is to have also a dashboard. You can deploy a dashboard. And so an example of a dashboard that will help you see now your brokers, how much data is in there, and you can even be able to see, let's say if you are saving names of people or your users, you can be able to click into the topic and be able to see the data in the topic. So of course, these in terms of the UI, because initially it was not meant for these UI, so these are third-party tools. They come with their complexities in terms of installation and configuration, depending on how you set up your cluster. So for example, I've had a case where I deploy a cluster and it's so secure that I'm having problem connecting my dashboard. So those are some of the things that you need to consider.
Yeah, we love UIs, right? Nsia, you mentioned ingesting data. I'm assuming this data is coming from different data sources. So I, played a little bit with Kafka, and one of the pain points I had was schemas and making sure that those schemas are, first of all, they work. How do you, from different data sources, ensure that you have visibility of schemas and that they're accurate? Is there some tools that you use for discovery, for instance?
I see. Thank you. So Kafka itself, there are two parts how we deal with those schema issues you mentioned. So Kafka comes with a centralized schema registry. That way, it acts as a repository where you can put all your data schemas there, and then developers or any other stakeholders could just view and then get a feel of what we have. It also has some sort of version control where you can say, okay, how far we have reached, these are the ones we are using, and so forth. Now that is on the application part, but there's also a human perspective here. So in a human perspective, I work with since I get data from different sources, we work with different developers, we work with different teams. Now, it's very crucial that I involve any other stakeholder related in the data I want to be there, and we all get into an agreement. This is a schema I will require. This is, if I want it, I require all my data to be JSON. Like you send JSON data in Kafka. You send that, this is the structure, this is how I want it. You send it the way it is, and then I'll continue, I'll do my ETL processing. So that's a very crucial part, especially in my part. You really need to involve anyone around so everyone is in tune to the goal you're going forward to get. So that is what I do. You involve first a team to make sure that everyone is in line to what kind of data you want to receive in Kafka, and then you let schema registry work. So also schema registry, it handles the data. So if I say I want JSON, and you didn't send me JSON, it ignores it. If it ignores it, me and the dev are going to have a problem later because where is my data? I cannot see it. Where is it? So we'll go back and see, what did you do this? So we have some other tools to help, like GitLab, to help consolidate the kinds of data we want, especially this is the exact format I want. So if you didn't go through it or something happened to your backend application, you go back and fix it for me. Yeah. So that's
okay. And I'll follow up really quickly on that. Together with the schema discovery, like how do you also ensure that certain people only access to the data that they're supposed to see them just themselves, i.e. access control? For instance, like you can imagine with Irembo, we've got a lot of sensitive information, but we don't want everyone to see everything. So how can we set up Kafka in a way that only the police see what they're supposed to see?
I see. So for that, I think it's a little bit outside of my jurisdiction. So we have infrastructure and DevOps guys that really takes care of that, making sure that this person access exactly this, like this sort of topic or something, and this is only what you're going to deal with, because we have thousands and thousands of topics, but not necessarily everyone needs to know what is happening. So our infrastructure and dev guys, they are just keen to just make sure that that happens. Yeah.
All right. Thank you. And Joan, I see you're very eager to share some of your secrets. You spoke about, actually, everybody here spoke about tolerance, fault tolerance, and that might be a bit of a jargon word. What does it really mean in like plain English? And why is Kafka important for fault tolerance?
Okay, thanks. I think plain English, fault tolerance, I was actually telling my friend here that it's just how your application is able to bounce back in very layman's terms. So in case of any disaster, if anything causes your application to go down for a particular reason, and I'll give you one. In my previous job, we actually had a data center go up in flames because I don't know what electricians did, and you guys know live and earth, and I don't know. So we lost everything. It was actually so funny. We can laugh about it now. But in the moment, it was chaos upon chaos and disasters. So fault-tolerant application means how do we recover from that as quick as possible. So my background is actually infrastructure, so allow me to say the first step is where you're running, and I feel like Kubernetes is a very good tool in itself. I think one of the features we talk about Kubernetes is reliability and fault tolerance and how it's able to restart your pods. Oh, it's magic, I know. So, running Kafka on Kubernetes, first of all, I think it gives you an added advantage as opposed to just single servers. Then into Kafka itself, I just saw our very experienced engineer talk about replication and in-sync replicas, how much, I think that's copies of the data that you have, so that in itself, making sure that you have at least more than one. So in case you lose one broker, you can have leader elections real quick, and you can have another leader, and your customers won't notice. Your Elasticsearch will not notice the glitch, right? Your data will still continue streaming as you're left to sort other issues. So I think replication and the replicas that you have on top of Kubernetes is a step in the right direction.
Okay. When you say things like leader elections, I'm thinking it's a political debate. But one more question for you, because I know the audience is itching to ask more questions. You talked about being able to recover. Let's say you've maybe added a new broker in your Kafka configuration, and this is mostly to you, John, but anyone can chip in as well. How do you ensure that you don't lose any data during that rebalancing, or that your data streaming is not slow or affected in any case, or when you lose a broker?
Well, that's interesting. I've never actually thought about it like that, because the way I support Kafka in my current role is I'm guilty. I just need to ensure that the environment is okay. But on top of that, so what I can say what I do in terms of infrastructure to make sure that you don't notice any glitch. So like for Kubernetes, there's storage, persistent volume. So I make sure that you reference the persistent volume. You're just still copying the same data, just a different. I want to use jargons, but I also want to be like very layman. But you see, look at persistent. I know you guys are techies, right? Look at persistent volume as this table, and look at the brokers as the water bottles. Okay, so as long as you're adding a water bottle to the same table, you are still exposed to the same surface area. Sort of, yeah. So for me, that's one. So make sure that where your data is, everyone can just access it, and you are referencing that actual data. That's what I make sure.
Okay. And with that, we'll be back for a commercial break. And we're back. Does anyone have any questions? Yes, sir.
Okay, thank you. My name is Jacques. And I would like to follow up to make a follow-up question around that. You suggest that Kafka takes up real quickly after there is a fail in one of the reads. So I wanted to know, like, is there a specific time which is really known that it takes to bounce back? Like I used the terminology used to bounce back. Is there a specific time that it takes to bounce back so that we know this at this specific time? There might be some services that were processed and they weren't delivered as it is. So I want you to be specific on that. If there is any time which is known, or if not, to know that too. Yeah, thanks.
Maybe before you do, let's just try to take a few questions at a time, so that will also help us with our answering cadence. Yes, sir.
Okay, hello. My name is Kaiser Ilomo. So far, I've learned that all the speakers, they seem like their infrastructure is implemented on Kubernetes. So my question is there any implementation of Kafka apart from Kubernetes? And if there is other implementation for Kafka apart from Kubernetes, what is the efficiency compared to Kubernetes?
Okay, that's a very good question. One more before we... Yes, sir?
So I'm going to direct this question and,
okay, no problem.
to the gentleman with stature. So, there is... for Kafka, it's very brilliant when you are transferring data in text, right? Very small data, very small, like 10 megabytes and so on and so forth. So when you are trying to do things like file transfers, where you have an arbitrary amount of data, it can be anywhere from 1 megabyte of a file to multiple gigabytes of files. Kafka, you face an issue with managing the size of information, and it's also an anti-pattern for Kafka. So just trying to pick your mind on what you think the best architecture for microservices that are trying to move large files between themselves would look like.
All right, so with those three questions, I think we can have our three panelists sort of do a leader election of who's going to answer which question. Yeah, you guys can take up which question you're comfortable with.
Okay, if I can go first. You ask a specific time for Kafka to bounce back. Well, interesting, because I think from what I have seen, I think you can define that delay period for rebalancing. So maybe say you're empowered. So if you want 5 minutes, 10 minutes, so it's for you to define that as you deploy your Kafka. But I think the minimum is 5 minutes. I'm not sure, I stand corrected. But that's a variable that you can change on your own and decide. Yeah.
Okay, does that answer your question? All right, thank you.
Okay, I guess it's me now.
Yeah, anyone can...
Yes, so I'll try to answer part of your question. And you asked about other examples where Kafka can be applied outside Kubernetes. Yes, so I think more DevOps will probably give you a better answer on that, but it depends. It also depends on your use case. So it depends on what you want to achieve with it. So for example, as when I started learning about this Kafka and Dutch engineering stuff, you can actually deploy it locally, and you can just start to test and see how does a producer and consumer work. If I put data here, where does it go? Okay, you can try and check. Like, it's very useful if you really want to learn on a very not so big, not so scalable applications. Just put it in your computer, try to see how does that inbuilt KSQL work. Does it work? If I send this data in this format from this producer to this consumer, can I consume from this topic, and so forth. So on the low-level application, at least for what I've done, you can try and jump start with this Kafka stuff locally on your machine. But I think if you have big applications or big use cases like what Irembo is doing, what Alltrans is doing, I think Kubernetes plays a big part. And they're probably going to explain it better.
Yes, Joe.
If I may.
Yes, please.
So I think the move to Kubernetes is mostly powered by tech moving to cloud-native applications. So that's why most applications you're going to hear are being deployed to Kubernetes. But again, following my data center story, the reason why we actually moved from one server, because we were actually running Kafka on single instances, and then moving that to Kubernetes, first of all, was to leverage on resourcing, because as more data comes in, you realize that you need a lot more storage space, a lot more processing power. So what you do with Kubernetes, it's kind of like brings all that together for you in the same platform. So you're able to leverage on the resourcing, and then on top of that, we said Kubernetes has its own advantages. So it's more of, you can run on a server, yes, but it's also more on technologies and how we are evolving and how we can make use of this added advantage that Kubernetes offers.
Okay, so Andrew, you want to move gigabytes of data via Kafka. Why?
He wants to build a new TikTok.
Yeah.
Oh, YouTube.
Yeah, so basically, just like you mentioned, it is an anti-pattern to move very huge amounts of data via Kafka. And we're talking of data above 1 MB, actually. So, and for you, if you were to consider 1 MB of data in terms of text, is quite a lot of data. But now when you talk of files, then it's very small. I've not had a use case to implement a queuing system or a messaging system for images or files across systems. So in that case, I do not have a perfect tool, for example, that could replace Kafka. Maybe I could help you after this, maybe look at some of the tools that could apply into that use case or could be better and maybe achieve the same kind of throughput that Kafka gives, and then get back to you. And very quickly, Jeremiah, if you will, in terms of how, if you want to experiment with Kafka, the easiest way would just to have a Docker container. So you just put a Docker image on your machine and say Docker run. And then and then you connect that to your application, and you have a working cluster like my colleague mentioned here that you can test and see how it functions. But in terms of fault tolerance, you kind of want to use tools that have been tested and are much more suited for that kind of scale. And very quickly on your question in terms of how fast you can have Kafka coming back up, maybe after some failure, it depends on what failure we are talking about. There could be data corruption. That would mean maybe you need to delete the topic and rebuild, which now will depend on how much data you're going to put back into the topic. Or it could be you lost one server and now it's coming back. And so for them to rebalance also depends mostly on the data and your network. So if your network is fast, you're using fast disks in terms of the storage, and you have rest data, that means you could talk even of milliseconds for the data to synchronize. But with a huge amount of data, it's going to take more time.
Okay, I guess, Andrew, you could go with Ben for hiking for more information. I see there's a few hands, but before we take more audience questions, I just want to bring it a little bit back to like reality, yeah, because I feel like we've talked a lot about things that are a little bit, up there, but a lot of us are really just building simple applications, right? Django, Laravel, maybe Express for that upcoming startup, right? Maybe with 20 users. At what point, like in my journey, am I thinking, let me use Kafka versus, let me just deploy on like cPanel?
I can start, yeah. So I think on a data engineer perspective, at the point you're going to start thinking, I think I should use Kafka from these applications. It depends on what you want to achieve as the end goal, at the end of it. Because most of the time, my work is well-rounded around the key thing on a business requirement. What do you want? What do you want to achieve at the end? You have this small website. It does you get data from the user or something. So what do you want to achieve from that data? Do you just want to get some sort of analytics that that tells you the user trends for a month or something? So and probably you want to get it most important in real time, as when someone is logging in. Is there a way I can get some sort of analytics based of this? So when you start thinking of a way to get analytics in a real time manner, I think that's a cue. That's a cue. You should start using Kafka.
Okay.
Yes.
So it's not the number of users.
It's not about the number of users. Yes. It's about the real time capabilities of it.
Okay.
Yes.
Well, we do a lot of real time data processing here at Irembo. So if you're looking to do more Kafka practice, we are hiring. So do check out our website for our career page. But besides that point, I think, Ben, maybe you might want to also answer that question in terms of what's your threshold? Like, why not just use RabbitMQ?
Yeah, I would say, first of all, is mostly the use case that you have. You want fault tolerance, you want high throughput, for example, then Kafka will be the right tool for that. You're afraid of technology, Kafka is not the right tool for you. So it has some learning curve, and of course you need to understand how to optimize the performance. So it's much more complex in a way. So if you just want to get started and get your startup up and running, then a tool like RabbitMQ, and you're just using it for queuing messages, RabbitMQ would be a very easy tool to start with. If you're looking for a little bit more complex use cases, you're looking at now more performance, you're looking at retention. For example, if you write something in RabbitMQ and you read it, you don't have it, you can't see it again, it's gone. But if you write it in Kafka, you can decide, I want to keep it for 1 minute, I want to keep it for an hour, or even for a week. So depending on the use cases that you have, I would say that is what should drive if you should use Kafka or not, and not the number of users.
Okay. John, if you have anything to say on this topic, please feel free.
Not really, nothing to add, but I think I can emphasize on the real-time, data, especially for me is in terms of monitoring. At the end of the week, your manager asks you, okay, so how many successful transactions have we had on MTN? And you're like, I remember there were 20 in the morning. Kafka will help you with answering that real time. Yeah.
And how many did you have this today?
Oh, you're waiting for an answer? Oh, okay.
Okay, we'll answer after this break. I think there was a question at the back. Yes. Let's take 3 questions and move on.
I have a question about Kafka topic partition. So, when Ben was presenting, he showed us how we can configure different value about your Kafka, how your Kafka can have different values. So, as you guys have been using Kafka for long, I know there is a pros and cons of configuring your partition of the topic. So, is there like a formula or a way you use to determine the number of your partition, the topic partition? Because if you have more, there's becoming overhead. If you have few, there is a management problem. Is there a specific way you determine? You say, for this producer and for this topic, maybe you can have this number of partition, or for this you can have this number of partition.
Okay, thank you. Let's take one more question.
Well, thank you. My name is Kevin, and I have this question can go to any of the panelists. So, what are the limitations while using Kafka?
Okay, that's a loaded question. Yes, Kwisa, you can ask.
Okay, my question goes to John. So she mentioned earlier that there's one time at your former job that the data center blew up in flames. So maybe can you tell us a little bit how Kafka helped you on a step-by-step, approach?
All right, so 3 questions for our panelists. Also here at Irembo, by the way, we have fire drills, so so we are very well equipped for any such situations. But yes, in your situation, how did you go about it?
Okay, that's interesting because we lost everything, including Kafka. And the reason is, so we had, please don't laugh. Okay, we had 3 data centers. So we have data center 1, 2, and 3. So we lost data center 3. Okay, so because the way we had set up our Kubernetes environment, we had, so I won't bore you with so many Kubernetes jargon, but we had an instance of at least Kubernetes components, the master and the slave, at least on every data center. So we had different servers. So losing data center 3 meant that we needed to, sort of rebalance. I'm using this term very lightly, so that Kubernetes actually understands that we have lost, that was coming to around 12 servers in a cluster of 36. So we had lost 12, so we were operating on 24. So operating on 24, the first thing is, I know Kubernetes is very self-intuitive, again, loosely, but we needed to deregister the servers, and then we had to get the deployments up and running. Unfortunately, it was one at a time because now we were in panic mode and we needed everything up as soon as possible. So first of all, we started with the applications writing to Kafka. And then once we had those, at least some replicas or up, the next thing was Kafka itself. So the advantage here was because of the data replication, we had instances of the same data in the other 2 data centers. So it was just a matter of having the pods, creating and reading the persistent volume, and they were up in about, because it was a lot of work, I'm not going to lie to you and tell you SLA was 1 hour. No, that's a lie. It was 6 hours to have everything back up. But we did not lose any data. So I think for Kafka, there's a way, I forget the name, they keep a track for consumers where you are reading last. So you just pick up from where you were. So once Kafka cluster and the nodes were back up, everything was back up. So it was, here mostly we were relying on Kubernetes waits because Kafka was gone.
Okay. We also had a question on, I think it was the limitations of Kafka in general, but also one on the partitioning. Yes. Does maybe Ben? Do you wanna which one do you wanna take?
Yeah, let me answer my colleague Bahati. So, in terms of partitioning and knowing the right partitioning to use for your environment, again, I would say it's an art. There is no specific number that you should assign because, for example, if you use more partitions, means you need more storage and you need more brokers. So if let's say you have 3 brokers and you partition the data 50 times, it means you're having the partitions duplicated on the same brokers. So you must scale the brokers, which means now you scale the partitions, which means you need more storage, you need more RAM, you need more resources. So it's an art. So I would say it's just like learning to swim. And there's no one particular way that it's easy for you to swim. So if we throw you into a swimming pool, I think you just try to figure it out as you go. Your natural intuition will kick in and you prevent yourself from dying. I'll assimilate that instance to on how you learn the right partitions to use.
Okay, thank you. And Sia, what are the limitations of Kafka?
So thank you. So I don't think if I should tell it as a limitation, but it's something that you should keep in mind, that Kafka is still a queuing system. Meaning, as you see Benson in the beginning, he put some sort of retention period. Like how long do you want the data to stay, to be retained in Kafka? So that is something that you should keep in mind, especially for me as a data engineer. We need data, let's say, in real time. So meaning you get the data, you have to find somewhere permanent to store it, where it makes sense to you in your business use case. So keep it in mind that the data you put at one point, it's a queue system, it will go away. So you have to find somewhere permanent to make sense of all the data you have collected according to a certain use case that you have.
Okay. In the interest of time, I'm going to sort of introduce our probably last segment to our panelists, and then maybe start to wrap up, because if you have any other questions, I guess maybe you could meet them up after our talk. But this last segment, I want us to just give a quick rapid-fire yes or no answer. So I'm going to ask 3 yes or no Kafka-related questions. I hope you guys are ready. Do you want to stretch? No? Okay. Ben is ever ready. Okay, cool. So we'll start with Joan. Okay. Have you ever used Kafka in a microservice architecture?
Yes.
Does your organization use Kafka for real-time analytics?
Yes.
Have you ever implemented fault tolerance with Kafka?
Yes.
Okay, all right. Okay, so 3 yeses. Great, cool. Ben, Big Ben. Is Kafka overkill for small projects?
No.
Ooh. Okay. Do you think Kafka can replace traditional message brokers like RabbitMQ?
Yes.
Have you ever had to deal with data loss in a Kafka stream?
Yes.
Okay. And last but not least, in Sia, let's see. Is setting up a Kafka cluster a straightforward process?
No.
Okay. Does Kafka simplify your data pipeline?
Yes.
Have you used Kafka Connect for integrating with external systems?
No.
Okay.
No.
Nah. Okay, I'll give you one bonus question.
Okay.
Would you recommend Kafka for event sourcing architectures?
Definitely, yes.
All right, let's give it up for our panelists. All right, so that wraps up our 7th edition of Irembo Tech Talk. I have been your host, Jeremiah, and it's been a pleasure, and thanks for all the questions. I do not want to make a mistake, but I believe we have a few refreshments after here.
Yes, okay. We do.
All right, great, because that would have been awkward, right? Okay, cool. So let's hang out, let's chill, let's exchange contacts. Let's go on Irembo's career page as well, and like, subscribe, and all those good things. Okay, thanks a lot. All right.
Thank you.
Thank you.